Let's discuss density of a material. So we are looking at the density of material. The density of a material is the mass per unit volume of the material. That is, density equals mass of the material over the volume of the material. So if you take the mass of the material, then you divide by the volume of the material, this gives the density of the material. The SI unit of density is kilogram per meter cube. It's kilogram per meter cube, and its dimension is m per L cube. And it is assumed that a fluid sample is largely compared to atomic size, and thus it is with uniform density. So if you take a fluid, we compare its density to the atomic size, or the atomic size gives the density of the fluid, and that's the fluid has a uniform density throughout. The fluid has a density which is uniform throughout. The density of a gas varies considerably with pressure, but the density of liquid does not vary with pressure. So if you take gas can be compressed to form the container to which it is in. But for liquid, we cannot compress as we compress gases. So gas can vary with pressure, and liquid cannot do that. So gas is readily compressible. You can compress gas, but liquids cannot be compressed, as I discussed earlier. Now, the quantity of matter that is contained in every unit volume of a substance is the density of the material. If you take a substance, the quantity of matter that is contained in every unit volume. So the unit volume is 1 meter cube. So we know that the standard unit for volume is meter cube. So a unit volume is 1. So 1 meter cube volume of a substance, the quantity of material that is present in that volume gives the density of the substance. It gives the density of the substance. Now, density also depicts the degree of compactness of a matter in a unit volume. So how compactable the matter is per unit volume also gives the density of the material. So if a material has a lot of pore spaces within it, and the compactness is a little bit less, meaning the density of the material will be less compared to a material which is closely packed with less or little pore spaces within it. With that, that matter will have a higher density compared to the one with a lot of pore spaces. So this means loosely packed particles or molecules of a material will have low density, and vice versa. As I said earlier, the ones with loose particles will have the density to be low, but with the one that the particles packed closely together with less pore space will have a higher density. So if you look at this diagram, this has a lesser density compared to that, because the pore spaces within this are very large. They are very large, and the particles are not closely packed together. Hence, the density of this material will be less compared to that and compared to the last one as well. So the number of pore spaces within it also affect the density of the material. So the closely the particles are packed together, the higher density. And when the particles are loosely packed, the density will be less. Now let's look at relative density of a material, the relative density of a material. And relative density, also termed as the specific gravity of material, is the measure of the density of a substance compared to the density of a reference substance, specifically pure water. So if you take the density of a material, then compare it to the density of pure water, then we term that as the relative density. We term that as the relative density. So relative density is the density of the material compared to the density of water. The density of material compared to the density of water. Then the mass of a substance can also be compared to the mass of an equal volume of pure water. So relative density can also be equal to the mass of a substance over the mass of equal volume of water. So if you have a substance and its mass is, let's say, A, you can compare that mass to equal volume of water. You can compare that to the mass of equal volume of water. And that will also give you the relative density of the material. So it is then deduced that relative density is ratio of masses and density. it is the ratio of masses and density. And also relative density is dimensionless and has no unit. Since we are dividing the same quantities, the numerator is mass, the denominator is mass, the numerator is density, the denominator is density. Their units cancel out, hence it has no unit and it is dimensionless as well. So relative density is dimensionless and has no unit. And the density of a material in gram per centimeter cube is numerically equal to the material's relative density. So if you have a material's density in gram per centimeter cube, then it means that is the relative density of the material. That is the relative density of the material. So let's look at some worked examples of densities. So a density bottle weighs 90 grams when filled with olive oil, but weighs 100 grams when filled with pure water. If the relative density of the olive is 0.75, determine the mass of the empty bottle. Determine the mass of the empty bottle. So we know the weight of the bottle when it is filled with olive oil, and we know the weight of the bottle when it is filled with pure water. We are coming to reduce the mass of the empty bottle. The mass of the empty bottle, since we are given the relative density of the olive oil. So let's look at how we will solve this problem step by step. So into our solution, we know relative density to be mass of substance over mass of equal volume of substance. Mass of substance over mass of equal volume of substance. So with this problem, we are using the relative density that is in terms of mass. We are using the relative density that is in terms of mass. So this is the equation we are using. Now, the mass of substance, which is the olive oil, it is equal to the mass of the bottle with olive oil minus the mass of empty bottle. So we just use some symbols to denote and differentiate them. So MO is the mass of the olive oil, MBO is the mass of the bottle with olive oil, then ME is the mass of the empty bottle. So this is our first equation. And now mass of water is equal to the mass of bottle with water minus the mass of the empty bottle. So the mass of bottle with water minus the mass of the empty bottle gives the mass of the water. So MW is for mass of water, MBW is for mass of the bottle with water, then ME is the mass of the empty bottle. So now I have these two equations. So we should take notes of this equation. So now we substitute them into the main equation, which is mass of substance over mass of equal volume of water. So this is our mass of the substance, and this is our mass of equal volume of water. So we substitute them here. So we substitute MBO minus ME to the numerator, then MBW minus ME to the denominator. Now, we have the mass of the bottle with the olive oil, which is 90. Then we have the mass of water, which is 100. Then we have the relative density, which is 0.75. So we will do our substitutions into the equation. We do substitutions into this equation. So after the substitution, you're having 0.75, which is the relative density, to be equal to 90 minus ME. So the 90 is for the mass of the bottle with olive oil. Then 100 minus ME, and 100 is for the mass of the bottle with water. The mass of the bottle with water. So now we are looking for the mass of the empty bottle. The mass of the empty bottle. So we have to make ME the subject of this equation. After the substitution, we are supposed to make ME the subject. So making ME the subject, we are having 0.5 multiplying 100 minus ME, which is equal to 90 minus ME. Then we multiply through by 0.75 to eliminate the bracket, hence giving us 75 minus 0.75 ME, which is equal to 90 minus ME. So from here, we group like terms. ME will go to the other side, then 75 and 90 will go to the other side of the equation. So we are having 75 minus 90 is equal to minus ME plus 0.75 ME. So we therefore divide through by ME. So dividing through by ME, we are having ME to be equal to 60 grams. We are having ME to be equal to 60 grams. So the mass of the empty bottle is equal to 60 grams. The mass of the empty bottle is equal to 60 grams. So having the mass of the empty bottle, we can therefore also deduce the mass of the olive oil in the bottle, then the mass of water also present in the bottle.